All right, ladies and gentlemen, this is probably going to be our last unit for videos, possibly um, gas laws. It's my favorite unit of that I love to teach every year. So let's get started. Okay, so what are some things that you need to be able to do? Explain the factors that affect gas pressures. Describe real world experiences and how they relate to gas pressure, temperature, and volume. And predict the behavior of a gas by changing one of its variables. So let's get started. In the video that we watched, I told you to watch for KMT. KMT makes three major assumptions about particles and gas, and KMT, if you didn't catch what it was, is kinetic molecular theory, KMT. Kinetic means movement, molecular is molecules, and it's just a theory. So, number one, their particles move in a straight line until they collide with other particles or the walls of their containers. So that's when they start bouncing around and moving faster. Okay, they have collisions. Number two, the motion of the particles is constant and random. Most of you guys know that gases go wherever they feel like it. Okay, there are no attractive or repulsive forces among particles. Make sure you have all three of those major assumptions down in your journal. Okay, all right, so four variables are generally used to describe a gas. Okay, and I want you to write all four of these down. Pressure, volume, temperature, and moles, okay, amount. So pressure, here's the thing that we need to make sure you understand. We have different units of pressure. We have kPa, which is kilopascals, and we'll talk more about these in class, millimeters of mercury, and atmospheres. This is the most common. This is the second common, and we sometimes use that one. Okay, volume, you have liters and milliliters. That's pretty common here, there. Temperature, always in kelvins for gas laws. So if you have a degrees Celsius, you have to convert to kelvins by adding 273, okay, which gives you your kelvins. Amount of moles, usually this is the N value in an equation, and we know how to calculate moles. All right, factors affecting gas pressure. Let me go ahead and get this up here. Effect of adding or removing a gas. So here's what we need to know. What's in right here? When the amount of gas in a given volume is increased, pressure increases, which makes sense, right? So doubling the amount of gas doubles the pressure. Kind of think of it like this, okay? Here you have not a lot of pressure. You double the amount pressure because you get more collisions and more bouncing around. More particles means more collisions, which means more pressure. Okay, so why does that happen? Well, just like we said before, you get more in there, you're going to have more collisions, you're going to have more pressure build up. This is a direct relationship. Okay, so as one goes up, the other goes up. So if we increase the amount of moles we have, we increase the pressure. Okay. I should have taken that slide out, sorry. All right, real world application, whitewater rafting. Oh, okay, here we go. The strength and flexibility of the rafts are important when you go whitewater rafting. Ooh, this reminds me, when I showed the video at the beginning of the year of me whitewater rafting with my daughter, that was very important. What would happen if the raft was deflating a little bit? Would you still be able to have the same capabilities? Probably not. So the raft must be able to withstand the pressure of the air inside the raft and the force of the rapids below. So if the raft is too inflated, the raft will easily burst. And that's pretty natural, right? I mean, you kind of can tell that. If it's too low, then you will not stay afloat. Okay, so other factors, volume, changing the volume. And remember, everything that's in blue, you definitely need to write down. When the volume of a gas is decreased for a given amount of gas, pressure increases. So decreasing the volume by half, the pressure decreases, okay? So increase the volume, decrease the pressure. Makes sense, right? You get more room, like in this one, less pressure. Less room, more pressure. Okay, so particles are closer together in a container, which means more collisions, and it means more pressure. So this is called an indirect or indirect relationship, or sometimes we'll call it proportion, but indirect relationship. So if the volume is cut in half, the pressure is doubled, and vice versa. So basically, as one goes up, the other goes down. All right, so real world application, opening soda cans and bottles. Soda cans or bottles are usually opened slowly because we learned when you open them too fast, they can cause a fizz up and spill over, right? So when you open the cap, the gas is suddenly to increase its volume, go anywhere it wants to, therefore decreasing the pressure in the can. Shaking. Okay, so if you shake the can, what happens? You mix the carbonation gets mixed with the soda, and before it can settle out, you get quite a mess, right? You shake it up and then you open it and it goes everywhere because you built up pressure. Okay. Another effect is changing the temperature. So you kind of can tell this also when the temperature increases, the particles have more kinetic energy. That's what Ke stands for. Ke is kinetic energy. Okay. The pressure increases. Why is this? Well, you double the temperature, you're going to make the particles go faster. They're going to collide more often, and you end up getting more. Okay, so the particles move faster when heated and strike the walls of the container with more force, so the pressure builds up. So this is a direct relationship. Again, as one goes up, the other goes up. Okay, so if the temperature is doubled, the pressure is doubled, and vice versa. All right. So here's how aerosol cans. This is why you do not catch an aerosol can on fire. A gas in a container can generate an enormous amount of pressure when heated. Okay, that's why all the labels on aerosol cans say do not store above 120 degrees Fahrenheit. Even empty, there's still some gas in there and it can explode. And if you ever have thrown an aerosol can into the flames, it will explode, and it's like a bomb going off and it can hit you. It is also wise not to store cans at temperatures that will freeze because they will expand when the can is punctured. Okay, so go back. All right, I think I got everything. All right, so write down any questions you have, bring them to class, and I'll see you in class.